So good morning, everyone. It's really a pleasure to have you here. Thank you for coming. Thank you, Peter, to be here in presence. And thank you all to the invited experts which are joining online. Yeah, some important information to start. Your microphone and the camera are muted. And the camera is off, but we will have some time for poll using Slido and Q&A chat boxes in case you have some comments or questions. The workshop will be recorded and available afterwards on culturally channels and websites. And here is the QR code to join the Slido to answer the poll. Shall we leave there a couple of seconds to let the people scan the QR code? I think, yeah. Okay. Oh, okay. So here is a test, right? For the Slido? Okay. Are you familiar with Culturally project already? Ah, okay. I don't see the number of answers, so it's 8. Okay. How many are we? Okay. That's good. So since about half of you do not know about the project, we prepared a sort of short introduction about it. And yeah, to just introduce the project to the non-familiar ones. Cultural E-Project is an Horizon 2020 project who started in 2019. And the main objective of the project is to define modular and replicable solutions for residential plus energy buildings. Taking into account climate and cultural differences and trying to engage all the key players involved in the building life cycle. You can have more information on the project website or by subscribing to our biannual newsletter. We have defined a framework to understand or to clarify what is a plus energy building. For us, a plus energy building is a building that produces over an annual basis more energy that it consumes. And it does that by also ensuring a good dynamic match between load and generation, and with the aim to reduce as much as possible the greenhouse gas emissions, the overall greenhouse gas emissions over the year and the life cycle. We like to call it a plus and not positive because it also, plus energy building also have an added value to the final users and also the community, providing accessible, comfortable and healthy indoor environment, providing easy access to, and providing easy access to the e-mobility. How we can ensure that plus energy buildings become the new building standard? In our view, we have 4 main pillars we have been working on in the project. The first one is to put the users or the household at the center, understanding users' need and guiding them towards better energy practices. Then to define tailorable technology concepts and set that can be easily applied in different contexts. And then to have an integrated climate and cultural approach. And most one of the last pillars, but not the less important one, and that's why we are here, is also to define viable business models that include attractive financial mechanisms and take into account about the co-benefits of plus energy buildings. So this is the question we are trying to answer within the project. How we can identify and evaluate the co-benefits related to plus energy buildings. The main aim of this work is to define guidelines for the co-benefit evaluation that can be used by real estate agents, building occupants, policymakers, technology developers, to estimate the co-benefits associated with plus energy buildings at both household and community level, to integrate these into the business models and the cost assessment of the overall real estate intervention, and to be used as marketing strategies to promote and increase the market uptake of plus energy buildings in the future. So why we are here? Main aim is to start discussing the methodologies that the Mediterranean Center for Climate Change, together with the Universityof Venice, is developing, and also to build up a group of interest about the topic. So we would like to, and we invited you actually to join this external advisory board of internationally renowned expert on this topic. And yeah, we would like to create a network and and to keep getting in touch until the end of the project, and hopefully also beyond, in order to exchange our experiences and also for us to get feedback on the topic. You can subscribe online at the link, or Peter, there's a form at the registration desk if you like to stay in touch after the workshop with us. Thank you.
So, thank you, Annamaria. Please let me introduce myself. I am Roberta Di Bari from the University of Stuttgart, Institute for Acoustic and Building Physics, Department of Life Cycle Engineering, and I'm really happy to be here and moderate this session on co-benefits. The structure of this session is made also for guide you in our work, in our task. So we will start with Samar, which will explain our understanding, our definition of co-benefits for the plus energy buildings, and then going more into the assessment methodologies. So we are providing two different methodologies, two different perspectives from Francesco Bosello and Andrea Bigano. And afterwards, we have also time for discussion feedbacks, but as also Annamaria already mentioned, this is a workshop. We will be active. There is the Slido, so keep follow the presentation. Yeah, so I will leave directly the words to Francesco. Samar, sorry. To Samar, which will start with introduction to the co-benefits for plus energy buildings. She will be online and she will present online.
Hello, yeah, good morning to all. Today we are here to discuss an emerging concept, that is co-benefits from a positive or a plus energy buildings. It is defined basically as the additional positive effects brought by a policy measure that occurs regardless of and in addition to the predetermined goals of the policy. So this is what the definition of IPCC fifth assessment report tells us about. Can I move to the next slide, please? Okay. Basically, when we go for an implementation of any solution sets or technologies improvement in a building, so we can have both the direct benefits as well as the co-benefits. The direct benefits are basically aimed at energy reduction, carbon reduction, and life cycle cost reduction. But in addition to that, there are several other benefits that are received both at the household level and at the community level. Like for example, at the household level, we may have an improved thermal comfort or acoustic comfort, visual comfort or indoor air quality, or even the safety or ease of use. These all be classified as the type being user well-being. Whereas the increase in productivity, lower cost of energy or lesser need for energy subsidies, and of course the lower maintenance cost will provide with us more economic opportunities. Similarly, at the community level, the co-benefits like the mitigation of climate change, biodiversity conservation of ecosystem, or conservation of natural resources, all this lead to a type of co-benefits which may be classified as being environmental type. Whereas the last but not the least, improvement of social welfare, mortality and morbidity reduction, and energy security may be classified as being of social impact. Okay, the next slide, please. Basically, in Cultural A project, we try to evaluate and quantify these co-benefits which are available at the plus energy houses level. But the co-benefits which from a positive energy buildings are mainly attributed to use value. Now some of the co-benefits have the market impact with them, or the market value or social value associated with them, like the energy savings or emission savings. So this type of co-benefits can directly be evaluated by a type of methodology called the direct costing, which my friend Francesco will be discussing in the coming presentation. And whereas there are other methods, there are other co-benefits which do not have the exact market or social or economic parameters associated with them as of yet, like the welfare gain from high indoor air quality or acoustic and thermal comfort, or for example, sense of satisfaction that we get from living in a low environmental impact houses. Since there are no direct market values associated with them, we go an indirect way that is not called the discrete choice experiment. In these methods, we through interviews, we assess the willingness to pay by the users for different attributes. This discrete choice experiments will be discussed by my friend Andrea Bigano in the subsequent presentation. So for me, I would like to pass on to the first part of the methodologies sections that we have with us today is Francesco. Thank you. Thank you.
So Francesco, you can start.
So good morning. Let me join in the presenter in thanking for the invitation, the opportunity to present. Let me introduce briefly myself. I'm Francesco Bosello from the University of Venice, and I'm also collaborating senior scientist at the Euro-Mediterranean Center on Climate Change. And within the scope of the Cultural E project, we are, let's say, in charge of providing the evaluation part of the co-benefits. And this means that we are trying to associate to the co-benefits some kind of economic assessment. As introduced by Samar, some types of co-benefit could be more or less directly matched to some activities that have a direct market value. For instance, if we produce more energy, we can immediately attach to this production a value which is the cost or the price of energy. Some other benefits cannot be so directly associated to a price tag, let's say. So here I'm presenting what we are are doing applying the first methodology that perhaps is somehow the simpler. So we identified which type of benefit, co-benefit, because to be 100% rigorous, co-benefits exclude also, because there are basically two definitions of co-benefits. One has been, of course, already mentioned by Samar, which is a policy, a strategy, a technology produces something in addition to what was originally expected, and this is a co-benefit. But specifically, in the case of houses, the energy consumption, so savings in energy consumption, are not directly considered a co-benefit. This is a benefit, but this is just a matter of definition. Here, we are assessing also the of course, the gains produced by the fact that we may consume less energy or be also producer of energy. Even though this does not comply 100% with the definition of co-benefit, but this is included. So this is the more, let's say, the easier part, because what we did, we tried to identify first what type of co-benefits are can be originated by the energy plus building or plus energy building. And then this has not been done by ourselves, also the economists, but our tasks start to trying to associate to those benefits and economic value. So this is not necessary. So basically this activity implied a sequence of phases where we started from the identification of all the potential benefits, then all the benefits that could be somehow evaluated economically, and then eventually among these that can be evaluated economically, what we have enough data to eventually assess. So we have this selection procedure. One thing that is very important to specify, and this applies both to the direct costing methodology, which is this methodology that immediately identifies some kind of market evaluation to price, let's say, the benefit, but also applies to the discrete choice experiment that Andrea will be describing. We cannot talk about co-benefit or benefit of plus energy building. We can talk about benefit or co-benefit of a plus energy building only if or in comparison with something else. So there is not a co-benefit per se, but this is a co-benefit or a benefit as long as this building or this technology provides some advantages compared to some existing reference case. So this is one important point of all the discussion. So when we are discussing about the co-benefits, we need to identify, for instance, the global warming potential associated to an energy plus building, the global warming potential associated to another type of building, and only by comparing the two, we can say that here we have really a benefit or not. It depends. Okay, and cultural E used as a reference the net zero. No, just because I'm not an engineer, so I would like to use the correct words, net zero emission building. And I would say that this can be also, I mean, this is a little bit challenging because we are comparing an energy plus building against a reference which is already very, very, let's say, environmental sustainable. So this could be also perhaps the first question that we can ask to the audience. So what do you think? Is it reasonable to use this reference or not? Is it too ambitious? I mean, this is something that could be interesting to know. However, the decision has been already made by the project, but we can, so the reference is the net zero building. But perhaps we could also, if this is something that the audience thinks is, we can also add a second reference. I don't know, this can be done quite using quite easily, assuming a standard current state type of building. Okay. So basically, and now I don't see, and my presentation will be very, very short. Basically, here we have the list of the co-benefits that we are able to evaluate economically. So this is the scrutiny that we conducted in the first phase of our work. We identify in the second column the indicator of the co-benefit, and in the third, how we can, which kind of direct cost measure we can apply. So let me just go. Now I need really to go here. So, okay, so for instance, no, okay, but okay, yes, sorry. So okay. Yes, so as you see, and sorry, the other important thing is that all these co-benefits need to be evaluated, of course, along the entire life cycle of the building. I didn't say that, but this is quite important. So we can have co-benefit. We need to see if eventually there is a co-benefit compared to the reference, but in the use of construction material and production waste. In the operational and maintenance cost, mitigation of climate change, potentially employment creation. Here we have co-benefit that could be both private or at the household level, and also could be social, okay, or at the community level. They are all grouped together. Reduction of air pollution, reduce ozone depletion, reduce formation of potential tropospheric ozone, photochemical oxidants. So a lot of environmental factors. Reduce of water use. So there are some, you see, these co-benefits are mostly related to production of pollution, but also waste, use of material, and ozone and climate change mitigation potential. So these are the co-benefits. Here we have the indicator that allows to quantify these co-benefits that are mostly, almost entirely expressing the quantity of polluting substances that can be emitted, that can cause the depletion or the deterioration of the environmental goods and services. And here, and this is the part that in particular we developed, here there are the indication of how to support quantitatively the assessment. So basically, there are different methodologies that eventually lead to quantify, to attach a price or a value to each physical quantity of pollution not emitted. And I will show you the example of typically of the evaluation of the global warming potential associated to plus energy building that is linked to the amount of CO2 equivalent gases that are emitted along the life cycle of the building. So, but basically we were able to find a lot of reference values for the substances emitted that have been computed not by us, but the literature proposes different methodologies, for instance, associated to the health impact of some of these substances, some other associated to the social cost. I will give you an example which I know better about the climate change mitigation effects. But basically it is possible to price the avoided the non-emitted quantity, or the quantity which are not emitted into in the environment. Of course, always comparing this with what a net zero building would do. Okay, so here we have a concrete example. The example is applied to what we are applying this direct costing methodology to evaluate the co-benefit in terms of global warming potential. In this specific example, not of the whole energy plus building, but related to associate to the technologies which are embedded in the building. So that we are working on to extend this to the whole building, but at the moment this example is for the technologies embedded in this energy plus building. So of course we need to specify the building. So we have a net floor area of 700 square meter, assuming that the service life is 20 years. What is the technology we are talking about? Is the warming cooling technologies applied there? So a mix of active window system of a certain types, a photovoltaic system of a certain types of dimension, heating floor panel of a certain type. And so here we have a very specific technological characteristic of the technology. We assume that this operates in that building for 20 years, and we apply, I should say, Stuttgart applied the life cycle assessment to this data. And basically the end, which is the starting point information for us, is that there is a total emission of 62.5 tons of CO2 equivalent. Okay, so how to price this? How can we translate this in economic evaluation? We use this concept, quite common in the literature, which is the social cost of carbon. Okay, the social cost of carbon is a measure of the whole market and non-market cost of 1 unit of CO2, which is 1 ton of CO2, the typical unit, emitted into the atmosphere. And it depends. Now, I don't. This is a very long story, but basically there are many factors that influence the social cost of carbon. Indeed, the literature ranges from values which are very low, almost zero, to here we have a spread up to $200 per ton of CO2, but there are estimates that are talking about 300, 600. For instance, I don't know if you are familiar, but with the Stern review of 2006, the social cost of carbon was $314 per ton. Okay, why there is this huge spread of values? Because there is uncertainty, and most importantly, because when we emit 1 unit of carbon today, it stays in the atmosphere for a long time, hundreds of years, and so it keeps on producing damages along a long time. And of course, the way in which we evaluate future damages, because eventually the total cost is the sum of all these damages a long time. But the way in which we evaluate the future damages, something that could happen 200 years from now, today influences the total evaluation. So if we think that the future is very important, something that will occur 200 years from now will still be very important. So we sum the total value. But if not, what happens to 200 years from now can be not that important. So in the sum, this value will be smaller. So basically, and this is the issue of the discount rate. But to evaluate these 62 tons, we used a ranges of values going from a minimum of 5 to a maximum of $75 per ton. So we are quite conservative. We are more or less here. Okay, and we simply apply this to the emitted tons. So we have a cost, a social cost, ranging from $212 to $4,600 of those technologies. Okay, so this is the cost. how can we say, or how can we compare these? So, or how can we translate this in terms of co-benefit? Of course, we need to know what, but you see that there is not here. We need to know what a net zero building or a technology or a similar technology applied in a net zero building would determine. That, but this, we still are working on this second part. But this was just an example of the methodologies that we are going to apply for those benefits that are directly associated or associable to a direct evaluation, which is somehow produced by the market. Let me say that in the social cost of carbon, for instance, we have already market and non-market component, but somehow indirectly this value has been already monetized. Of course, there is the problem that there are many or some benefits or potential benefits that are not priced by market, and Andrea will mention this second, more complex evaluation methodology. And okay, I will stop here also because it was really an example, and don't want to be too boring. Okay. Yes, of course.
This is Peter Satcher. So just trying to read the statistics here.
Yes.
The cost of removing 1 kilo of carbon today with the air suction unit that's on Iceland is approximately €1 per kilo. So that's the cost of direct removal of carbon. Do I read this correctly, that with that in mind, I mean, we can afford to actually pollute quite a lot because the carbon cost is low?
No, this is per ton. No, but
yeah, but I mean, if you
no, this is the cost if you emit. Okay, yeah. This is the damage that you would produce by emitting. So that ranges from okay, in the 90%. The interval is between $5 and $75 per ton. Okay, so this is the cost. If you say removing 1 ton costs $1, it means that
no, it's 1 kilo.
1 kilo.
€1.
€1.
1 ton. €1,000.
Okay.
So I'm asking myself, is it cheaper to pollute?
No, absolutely not. in the sense that in terms of direct costing, honestly, it seems so. But if you look at the damages, usually the cost of mitigation policies is rather low. For instance, it has been estimated that the targets, the mitigation targets of the EU for 2030 are going to cost negligible GDP, have a negligible impact on GDP of the EU. The study from the Commission talk about 0.34%. And it could be also, there could be also gains if the money that we can obtain by applying those policies, because anyway, there are some forms of taxation of pricing of carbon are used in a proper way, we can have positive effect compared to a no policy case. Whereas also in the short terms, medium short terms, between 2030 and 2050, the cost of an unmitigated climate change is around 2.5% of GDP. So looking at the policy cost and policy benefit, the balance is totally the other way around. Okay. Because what is different is that here we are somehow making a direct cost comparison. So, but we need also to look at the effect of the policies in terms of potential impact and also potential stimulus to the economic system if we use properly the opportunities that this policy are raising. So this is basically my answer.
Yeah, you basically pick the most expensive way to tackle
Yeah, I know.
climate change. So there is a whole spectrum of much cheaper options. There was a very famous graph by McKinsey.
I see.
And you really pick up the upper part of the spectrum, but there are negative also things that gives benefits, basically, like things like increasing the efficiency in buildings. That is something that we're trying to do here.
No, thank you, Andrea, for because I didn't got the key point. But indeed, yes, indeed, the carbon removal is the most expensive. It's so expensive that, for instance, the MIT removed the option from their simulation because it was really never coming into play because it was very so costly. But at the same time, there are a lot of other opportunities where the costs are much lower. Of course.
Well, thank you, but well, maybe this is probably too early for the workshop. But of course, I acknowledge that removing carbon from the atmosphere is very expensive. The problem about increasing efficiency is that then when you increase efficiency, very often you will see the demand rise as a result. So you don't save as much as you predict because the behavior changes. But that's another discussion. But thank you very much.
Yes, but this should be also associated to the right incentive. So the right price signal, because that's true. You can also have a typical rebound effect. You are more efficient in the use of energy, you use more energy. Absolutely true. But the point is that if the market or the policy gives you the right signal, you may want to use more energy in the right way. So this rebound effect, which is unavoidable, can be really reduced to a minimum. But yes, I agree. This point is totally true.
So thank you, Francesco, for your presentation, and thank you for showing us the direct costing approach. Now, going forward with our workshop, let's see the other approach of the discrete choice experiment presented by Andrea. Yeah.
Hello, everybody. Thank you also from my side for this invitation to speak about co-benefits and the way we can evaluate them in plus energy buildings. So my side of the presentation is about the follow-up of what Francesco was presenting. So what we cannot directly put a price tag on. So basically the idea here is to go and ask people what they think about it. And there are methodologies to do that, which have been developed and refined to work in a hypothetical experimental framework in a way that try and reduce every possible psychological bias that you may have to come to a reasonable estimate. Of course, they are not immune from criticism, but this is the best weapon we have at disposal to do that when there is no real price, directly or indirectly available. So what we do, what we plan to do is basically try to ask people in two countries, French and Germany, this to capture a little bit heterogeneity across European building stocks, about 10,000 people what they think about these co-benefits. And we are now in the process of building this questionnaire, and the questionnaire has to go through really a painstaking, slow but accurate design phase in order to really phrase everything in the correct way. And there are many angles that we have to cover in order to be able to bring about the right meaning. For instance, we have to decide which kind of co-benefits we can ask people about. There are so many, and the attention span of people when facing a questionnaire is limited. So we have to cluster co-benefits into meaningful clusters and describe then those clusters in a way that captures really the non-market aspects of those co-benefits. So really go to things that have no market, no price tag. So we are actually defining this questionnaire. The other thing, and this is to a certain extent already be done, is include realistic ranges for attributes. This is also thanks to EURAC, Stuttgart, and so on, our technical partners. We had discussion about what can be the ranges of those aspects of the co-benefits which are realistic given the characteristics of the plus energy building. We also have to consider different kind of people. For instance, people who already have some experience about improving the energy situation, they're building those which are not, because there is this effect that is always mentioned that if you have experienced something positive, you may want to, you don't want to go back to a previous situation, so your willingness to pay may be different. So you have to take this into account. And also we have to consider, this is an important point that I'll come back later, what is your housing situation, whether you own, whether you rent the place you live, and so on. Then we have to test this questionnaire to see if what we are writing is reasonable, and then we'll have to administer this questionnaire to those people using computer assisted web interviewing. So basically, people will have to sit in front of a computer or a tablet and answer those questions. Of course, people are recruited in a professional way through reputable survey companies. That mean that those are samples which are really representative of the population, and they are, most importantly, their time is paid in some way. So they really have some incentive in terms of discounts or points they accumulate, or even real money to do the best they can in terms of the information they provide. And from that, we will start with once we have the data, start with our econometric analysis. I will not bother you with the statistical details of the theory behind that, but basically once you have a picture of those preferences, you can imagine that they are supported by distribution function. So it's a probability distribution which is realistic, and based on that you can make inferences about the likelihood that people will have express their opinion in that way, and from that you can build a model, a statistical model of that which represents what you have observed, and then you can put parameters capturing how much those various effects are important for the people, and from there you can put finally your price in terms of willingness to pay. So what we are doing now, we are developing the general question section of the questionnaire. We have, as I said, have a first attempt to identify the attribute levels and realistic ranges. We are considering expanding the scope of the energy balance and attributability. That means that I will show you later what this means, but basically we need really to adjust the attributes in a way that capture the non-market aspects of the co-benefit. So we have to stretch a little bit the definitions. And as I said, it's important to accommodate various types of dwellers. So we need to refine the definition of how much people are willing to pay, and in which way. So this is the co-benefits we are starting from. So we were given this list of co-benefits which in principle have no direct price, okay, which start from indoor quality, air quality, environmental quality, indoor. So basically, indoor environmental quality attributes, which are divided into air quality, acoustic quality, comfort, local pollution, and so on. And we try to make them into meaningful clusters. You see there is also, we kept also here energy consumption, which is, again, as Francesco was saying, the main direct benefit of the energy plus building. We try to capture here things that are, yes, directly connected to energy, but also have some other less material but important effects. For instance, as I will mention later, the importance of energy security, and so on. From that, we basically got to a final clustering, which is energy balance, which is, again, what I was just saying, the indoor environmental quality, which put together all things that make you feel well within your housing unit, the ability of the building to adapt to different needs, different situation, also based on various kind of technology you can use. For instance, you can imagine integrating the building with your mobility needs through charging stations for your electrical vehicle, the ability of the building to be very easily reached through remote control apps and so on. And of course, we need a price. So what you would pay in a way or another to have your building unit having that characteristics. Okay, and this is important because that attribute captures actually the willingness to pay, and the way it interacts with the other attributes captures the influence of the various co-benefits on the willingness to pay. So the questionnaire will have a very definite structure. There will be general questions of this kind. So things about the experience about the building, where the place where people live, the main feature of the building, the experience in terms of energy efficiency. This is all to understand how much people understand the problem, and if they have had any previous experience of with a situation in which energy has been improved. And these things can become variable into the econometric model that can be used to control for this kind of effects. Again, the familiarity with some co-benefits, if they know or well what is happening in their buildings, how much they are sensitive to the situation in which the air quality could have been negative in the past, like if they had mildew, dampness in the building. So if they are really keen to have a better situation or not, or if you had problems with energy security in terms of being left without energy supply for a while. or their expectation in terms of having this kind of negative experience in the future. So what we are trying to figure out what is the general framework of the mind of people we are going to respond. And then there will be the actual discrete choice experiment, which I will describe in a minute, with ideally three versions according to where people live. If they are renting their place, if they own the place and they are not considering to move, or if they are renting the place and they are considering to move. And then there will be the general social demographic questions. So this is the core of the exercise. So basically, imagine you are sitting this experiment, and you will be presented a more detailed card like this, in which you have a choice between three situations. One in which you have the status quo, so that the situation which can be either the reference building near zero, or the average situation of the buildings in those two countries, compared to different levels of the attributes that we have been discussing. And you will be seeing these things 10, 12 times. And you always there will be different levels and different combination. Based on your answer, the data then we will provide a distribution of the answers and among the sample, and from them we could derive our estimation of the willingness to pay. Of course, there will be a clear illustration in clear terms, with clear words and perhaps also visual aids to make clear the ideas that we want to convey. There is main questions about the cost, because it's very important. It drives the willingness to pay, and it varies with categories of responders. So people who rent, we can expect people who rent their place to be able to reason in terms of their variation in the rental cost, the thing they pay every month. We have to figure out if they can expect that to be correlated or not to the quality of the place that they are living. And so they will be able to capture these effects. People which are not planning to move may be more likely to respond to a situation in which you propose them the idea of making renovations, bringing about similar changes as those that you will have in an Erasmus Plus building. But only people that may be considering to move may be considering really seriously the idea of paying a full price for a new house, or the characteristics of the plus energy building. So we need to cover this spectrum, and we need to really think about it in terms of how to frame this question, which is tricky because you don't expect to find many people really considering moving to a very efficient building in any moment in time. So we need to cover all these kind of aspects. And for that, we will need really to test the questionnaire to see how people respond, and how perhaps the focus groups, people like you, can have what are their opinion about the likelihood to have people responding to different idea about this cost attribute. So our next steps would be to finalize all the refinements of the questionnaire, to assess, for instance, the housing market at this unusual time, and to determine whether this is a good time to ask people to answer questions about the potential purchase of home. This is because at the moment we are living a very important energy crisis. Prices are skyrocketing and so on, due to the gas crisis. So it may be a moment in which people may be very anxious, and the answer they give today would be different from their long-run answer. So we have to a bit see how the situation evolves. We need to also assess how, I was mentioning, if renters could really appreciate their willingness, the opportunity that these kind of things provide, or they will consider them constrained by the decision of the landlords, and so they may think that they have nothing to do and they will not give reasonable answers. And we also may consider more integration with direct costing for things that may look suitable for DCE, but they may actually be done through direct costing, like, for instance, domotics, which have a price. We need to really think about it. And then we have to finalize all the technical parts. Thank you.
So
I need to. There were different.
yeah, we have 3 slide of questions after this, and then we have time for question and answers until the end.
Yeah, but I was intending to talk about 2 things which are not. Yeah, basically the idea was to. I mean that in the. So I probably mentioned that in the energy consumption clusters, or for those kind of attributes, we would need a little bit to expand the framework. So we were considering giving more space to energy security kind of attributes, and how people feel about energy security, and also how they feel about being integrated in a system where energy is exchanged, maybe exchanged within energy districts, energy communities, to increase their sense of security. So this kind of variation of the non-cost part of energy consumption would be interesting to develop, given the time we are living now. So this was the part that I was expecting to see a slide about, but that is somewhere gone. But anyway, so we will see if there is something in the slide that can happen. That okay. Thank you.
And thank you again, Andrea. So now it's time for the interactive poll. So, but there is.
More questions. Just for my understanding, do you imagine that you, I wonder for this questionnaire with the different options, do you ask them based on their present experience, the home that they live in, or do you sort of ask them to imagine some sort of baseline of a building quality, energy system, and so on? I mean, what is the baseline, basically?
This is an important question, and we have to define very carefully the baseline. The thing that we are kind of the mandate to do was to use the near net zero buildings. But the point is that in the experience of people, that could be very hard to imagine as a baseline. So that they, at the moment, I was looking at the statistics. The diffusion of near zero building is really very low across Europe in terms of the probability that people living there and knowing what is there is quite low. So I was considering, and that will be done in the test, to do that with the average situation of the building stock in the country. But they will probably refer to what they have in mind, in any case, to what there is the experience. So that the base case should be closer to the experience of people as much as possible. And so this is what makes me a bit worried of using the near zero as a reference in this case. You can always then adjust the thing. So considering the situation how is the situation of the near zero building compared to the energy plus, scale up things. But yes, it should be bring closer to the experience of people as much as possible.
Just a suggestion. I mean, it could be maybe it could be idea to group the respondents according to the building energy certificate of the building that they live in, for instance. I mean, because that would assume a certain level of energy efficiency, which often will correspond with the building properties as well.
You mean the label, the energy label? Yeah, that's an option. But the point is, it has to be the same for everybody. So I was more considering an average of the situation in the country as a reference. So because otherwise you will be comparing different things for different people. You need to have a common reference to make things
the question is then, how much do you stress the imagination?
Yeah, there are techniques to present things in a convincing way. We will have to. There is always this important phase of testing to see how it works and to adjust things.
Yeah, thank you. If I can add also a further idea, since we are also here speaking about existing buildings, so the existing building stock, it's also true that we are experiencing the renovation wave, which is the call that it's the European call for all the existing building stock. And I think in the future also there will be more operative guidelines and more operative approaches for the understanding the reference building for the existing building stock. So which building will have still market or value in the market, and this may be used eventually as a baseline. This, of course, we will have several scenarios because there are existing buildings, there are historical buildings for which we still don't know if it is possible to reach a net zero energy balance performance or a net zero emission performance. I think the next stages or the next years will also provide us more insights on this topic. And now let's start with the active poll. And the first question is, in your opinion, what is more cost efficient overall? And here we have 3 different options. So. Okay. Let's wait a little bit. We have still few answers. So we collect 16 answers. I think now will be still increasing, but we have already, I think we have already a clear picture of the overall opinion, which sees more as cost-efficient approach performing a deep energy efficiency renovation in the existing buildings, which is kind of what is also, which is our common calls from in the European context. Yes. So the next question is, what is the most appealing feature of plus energy buildings for resident households? And here it's also possible to have a multiple choice. So we have indoor comfort or energy cost, and then extra security stemming from self-generating energy, and contributed to decarbonizing the planet. I'm curious to see if someone will propose other approaches. Yeah, we have already 16 answers, and also here, and also in my opinion, it's also the overall situation that we are experiencing at the moment is really appealing for plus energy buildings, the negligible energy cost. I think this is really an important feature. I don't know if you want to add something.
No, this is interesting, and the question is how then developers will factor this in the price, and how long it will take for those people living there to make up for the difference, to recover the difference in price. So it would be also interesting to see what is the market price of the buildings in the end.
Yeah, it's just one comment regarding this difference between net ZEB and plus energy building. I would say that these features are also very appealing for a net ZEB. For example, the costs, the energy costs, are not zero, but they are really low for the tenants, for example. So I don't know if, because the question is for plus energy building, but if we would have the same question with net ZEB, it would be, for me at least, the same answers. So yeah.
Yeah, but it's also true that the effects are scalable on higher levels. So not only on the neighborhoods, but also on the national level, you are improving also the grid, the national grid, and this may be then, let's say, other effects that can be provided on higher levels. So I think here is higher if we are looking on higher levels as well.
No, yes, because there is a difference between the question and because you are totally correct. So if you ask the same question to the owner of or you put the NZEB building and NetZEB, you have exactly the same. The point is that the effort is to try to quantify the difference. Okay, so and this is exactly what with the choice experiment we're trying to do, to find this incremental difference. But this is very challenging because the references are quite close. I would say not under the energy point of view, because here we are producing, let's say, but many other characteristics are quite close. So, thank you.
Yes, I am. There's still a question.
Yes, yeah, I have one question online from Suran Chatterjee. The question is, hi, congratulations for such a great framework. What types of proxy prices you plan to use for health impacts?
Okay, this is one. Okay, this is for sure one of the most difficult factor or gains to evaluate economically. In the evaluation of the social cost of carbon, so also the health effects or the damage to health induced by the emission of greenhouse gases is part of the evaluation, and usually is evaluated through mortality and morbidity, then on their turn evaluated applying techniques like the statistical value of life, or the statistical value of life, or the life of a year diseased. So there are these methodologies that attach some evaluation referred not just to the ability to produce income and wealth during your life, but also to the say social cost of illnesses. Okay, so there are these methodology that are applied already in the social cost of carbon. For other types of pollution that could be related to, for instance, air quality, that is not directly connected, is only indirectly linked to climate change, for instance. This exactly the same methodology are used to translate emission in terms of changes in mortality, morbidity, and there are evaluation methodologies that eventually enables to price this social cost. One could also, in principle, use one could use the insurance company tables, so for accidents, but it is very rough, and also people are uncomfortable with this very, let's say, particularly crude approach. So so one death is 200 times the income. So depends. So if you earn a lot of money, your life worth much more than if you earn okay, but this is what insurance companies are doing. But the value of statistical life, values of years disease are more refined. They take into account also the social cost dimension of this.
Can I add yeah, I just wanted to add a comment again on the difference between net zero and plus energy building. It is true that it is not easy to have a common baseline for all Europe. Net zero energy buildings have been declined by each state member in many different ways, but I do see quite a significant difference between net zero and plus energy building, in the sense that there are many things that we are considering in the definition of plus energy buildings that are not in the net zero one. For example, starting from the kind of energy demand that is taken into account, plus energy building considers the overall consumption, including also the appliances for the users. They have a flexible, they should provide a flexible asset. So there is an added value in being ready for sharing the energy with the local energy community. There are benefits at, as we said, at community level to let's say reduce the loads on the energy grid. There is an added value in terms of indoor environment quality overall. So far, net zero energy buildings just claimed to have a good indoor environment quality, but there has been no common way to demonstrate it. So I do see quite some different added value compared to the net zero energy building, which are, I understand, not that easy to address and evaluate, but yeah, I would not neglect these points as well.
So another reaction from the audience?
Yes, and another question from Anonymous. Great work. Will you also consider the co-benefits at the level of plus energy neighborhoods? Maybe I can add here that we're going to have a workshop after the lunch break with projects that look at plus energy neighborhoods. But yeah, who would like to take this?
Yeah, so thank you for the questions. Let's go with the next one, if we have another one, or just an open discussion. Oh, there is still another question. Yeah. So what do you think will be the rate of plus energy building homeowners in 10 years from now? So 1%, 10%, 20 or 50 or more? Quite pessimistic, the first answer. And now they're getting more positive answers, but not so positive.
But we need realistic answers.
Yeah.
Not optimistic or so.
10% is the
It's
core
also
target, actually.
Yes, so it's more directed to 10%, more and more 10%. But we have a 14% of 28% of really optimistic people. Yeah, I think we have an information. You want to add something?
Yeah, I mean, this give an idea of a rough idea of, oh, sorry, I think I muted this. Of how many people may be likely to actually invest in such a building in the next 10 years. So we are looking probably at 10% of the people that are considerable. No, the people, yeah. The people that help on
The microphone is muted.
It's supposed to be working. It's not. Oh, no, it's muted. Yes. So I was, yeah, that works much. Yeah, no, it's an important information because that means that, yeah, we can expect 10% or something between 10 and 20% of our sample to be actually considering the house pricing.
Yes, so anybody wants to? So one more?
No.
Or no, we are finished, but we still have time for few remarks or other discussions and feedbacks from the audience. Let's see if online someone will react. Ah, there is from the audience.
Thank you. I'm very interested in the model that you put into the choice card experiment, because the model attributes and the quality levels, that's basically how I understand the framework. I think that if you look at, I mean, you've been through the various quality, the various attributes are of course associated with the energy supply, but also the building base quality. I mean, is it an energy efficient building or is it not? How does that translate into indoor environment, and how does that translate into the user experiments? And these various levels are then, or people are then asked to assess various levels of quality and give them a price tag, more or less. Is that correctly understood? No?
They are similar. The price tag is for the combination. It's not working again. Okay. The price tag is for that combination, and you will see like 10, 12 such combinations, and you are not given the ability to say a price. You see a price. Okay, and you choose a situation where, for instance, you have very nice indoor quality, kind of medium energy conservation, and the price of X compared to another situation where you have reasonable indoor quality, very high level of conservation, and price Y, and then the status quo. And you're given these several times, and you have to say, I like A, B, or C. And from that pattern of choice, repeated over 10, 12 times for people, over 1,000 people, you derive a distribution of those attributes in the population, or those choices of attributes in the population. And you can assume that this is consistent with a model of indirect utility, and whose arguments are, among other things, these attributes. So you can put a weight in the utility that people receive from those attributes. One of those attributes, one of those explanatory variable is the price, and by deriving the value of that parameter attached to the price, which depends in the model from all the rest, you can also then, by derivation again, find a marginal price for all the other attributes. You basically make the ratio between the attributes for the price and the others, and that gives you your estimated willingness to pay. It's quite straightforward model to see in formulas if you are a bit familiar with probabilities distribution, or you derive likelihood. But basically, yeah, it's a way. There is a way with standard, quite reasonable assumption of the way you take into account probabilities in your mind, that these will give a reasonable value to the various attributes. So if people don't put directly price, they choose among prices. And the important things that we need to do with the technical people and the people which are in the project, which have to do with actually building and distributing, placing these buildings in the market, is find reasonable ranges for all these attributes, including the prices.
I think it's super interesting, and I just compare it to the process of buying a car, for instance, right? I mean, there's some money that you pay to get the car, and then there's the money that you will pay in order to drive the car. So there's sort of an sort of like buying and operating the building. In the case of designing these options that are going to be rated, in the question is, there's a very there's a tricky point, which is that if we're working on existing buildings, then you would have to package how much of an intervention is necessary in order to achieve a desired quality. I mean, you need to pay for maybe insulating the walls in combination with replacing the energy system, in combination with option 1, 2, 3, 4, and so on. And each of these have a price tag, and each of these result in different qualities. So it's very complex, and operational costs.
Look, we don't need to be super accurate on putting these prices. If we could be that accurate, we wouldn't need basically this exercise, because we would need a lot. We already know a lot about how it is priced in the market. We need to have ranges which are reasonable, in which we can put those values. And you are really, really correct. You really pinpointed the right example for the car, because the car is actually a bundle of services. The basic one is bringing you from point A to point B, but then you can do it in luxury with a premium car, or you can do it simply with a small car, and you can consume more or less fuel in doing that. So it's really a combination of options, a car, and the way you choose, you balance those options, and in a way that gives you the best compromise for your budget, really tells you a lot about what you really want about your car. And you can put a price implicitly or explicitly. In the car is explicit because you pay for that. But imagine you don't know exactly, there would be characteristics of the car that you cannot really price, like the pleasure of driving smoothly, something like that, or the sense of safety that gives you to drive an extra safe car, that you really to capture in other way.
Yeah.
But This is it's really the idea of a bundle. It's what is.
Yeah, I understand that. What makes it tricky is that in the built environment and in people's homes, it's not delivered, from a factory. It's happening inside your home. So there's, I mean, we're basically talking about retrofitting scenarios. So the price of inviting the contractors to remodel your home is of course high in monetary terms, but it's also very high in terms of not being able to live in your home. So I think that there are some externalities that are really very important barriers.
These can be should be considered, and you can probably control that with another question about the importance of being able to assess your home or something like that, and the discomfort that renovation works that brings you. So you can have a separate question and interact that with the questionnaire, the choice example, pretty much as you do with your experience with similar. No, it was working, yeah, with similar experience of renovation in the past. So this is something you can probably interact with the model with a separate question.
So thank you. There is another question.
So we have one more question online, and then we also have Lorenza online. I don't know if she wants to say something, and we have only 3 minutes left. So no pressure. The question is, could you please elaborate on the social benefits other than health being quantified in your methodology?
Okay, so first of all, we cannot evaluate all the social benefits. Most of the benefits that can be evaluated are related to the environmental dimension. And the environmental dimension is related to different types of environmental impact. So we have greenhouse gases that induce a certain type of environmental impact, which is increasing global warming. Then we have other types of emission that have another impact, which is in worsening air quality, other type of pollutants that affect the ozone layer, and so on and so forth. Okay, so the social costs of this impact are mostly referred to health, but there are also many dimensions of the impact that are related more to straight economic activities. So if we take the example of climate change, the health impact of induced by greenhouse gases is just one of the potential negative impact, very important. But there are also, for instance, impacts on the agricultural activities through the effect on changes in crop yields, which are on their turn defined by potential intensification of extreme events that are both droughts or also heavy rains and changing precipitation patterns. So there are all a bunch of impacts related to the agricultural activities that has nothing to do with health. There are potential losses of capital assets because, again, intensification of extreme events. So we are losing or damaging, or we need to spend more to protect our infrastructures. And this is related to floods, but also sea level rise. And this is another impact that has nothing to do with health. So you can, a legitimate question could be, but how can you then evaluate all these and tell me that 1 ton of CO2, eventually considering all these impact, then could produce a damage between $25 or $1,000 per ton? Okay, this will be a lecture, but basically there is models are used to translate all these impacts together and evaluate the potential effect on the economic activities, and then they are basically divided by the amount of emissions that the economic system produces, considering the delay in the life in the atmosphere and so on and so forth. But I mean, these are, I think, are the most direct example of non-health impact of emissions. So in the case of climate change, it's rather easy to at least list them, because there are effects on agriculture, effect on infrastructures, effect also on labor productivity. For instance, if it is too hot, people are less productive unless they are using air conditioning. There are all these type of impact that are not health related.
Yeah, if I can add also something.
No, of course, we are taking this evaluation from the literature, so we are not doing ourselves all these type of complex evaluation, just a little bit of them. But there are, luckily enough, there are the information that enable to take into account this type of impacts.
Don't worry, I was just adding something that is pretty connected to your last remark. So when we are talking about social dimension, there are a multitude of indicators or characteristics that can be analyzed. Some characteristics are more related to the socio-technical quality or to the social, ecological, social, environmental quality, and then there is the social but also economic quality. So some aspects that are related to the social quality in the overall are really interrelated with other dimension, with other aspects. And in this sense, it's really important to understand the social co-benefits and which is the interrelation, where it's coming from, this interrelation. While when we are talking about social sustainability, which is more general definition, it more involves the neighborhoods, the communities, the cities, and of course, this is not the case of the project because we are, or at least the focus is the building itself, so it's not possible to analyze all the effects on higher levels on the community and all the neighborhoods. Yes. Do we have some other remarks from Lorenza, which is online?
No, I'm just checking those questions at the moment, but no, I think so we're done with the questions, we're done with the polls. If Lorenza wants to say something, we can put her on, and we're slightly over.
Ah, okay. So that was a fruitful discussion, in my opinion. So I thank you everybody for the question, for the reactions, and for participating in this workshop. And I thank you also the speakers for presenting the results. And enjoy the break.